7D, we're talking about lists and bowling. So how this works is we're going to build a bowling bowls where all the pins are placed in line, basically. And our first input's going to represent the number of pins, and our second input's going to represent the number of balls that we're going to throw at these pins. Now these inputs right here take a value. So 2 and 5, our pins start at 1. Unlike our lists, which becomes important, our lists start with index 0, but our pins start with index 1. 2, 3, 4, 5, 6. So 2 and 5, these get knocked out. I's represent pins, dots represent knockdown pins. This is 8 to 10, so 8, 9, and 10 are knocked over. And this represents 3 to 6. Now, 3, 4, and 5 already got knocked down, but 6 gets knocked down at the end. And that's our result. Now we can have a variable number of pins and a variable number of balls. And this talks about K, and sometimes you have to write things down to understand what they mean. So in this case, it calls balls K to be rolled, and the number of pin is N. So anyway, our first input right here goes in the form of a list. So we could change our names to more meaningful names. I know a lot of you like to use A, B, C, and nonsense like that. I'm going to go ahead and, oh, for God's sakes, decline. I'm not even going to restart this video. Turn my phone off. Do not disturb. All right, let's go back. A0 is what we're going to refer to as pins equals A0. And ball is going to be equal to A1. Number of balls. So let's represent these pins. So for I in range, and let's say pins. And what we're going to do is say, let's do a list. Let's make a list visual. Some of you might be tempted to represent this as a string, but remember the term immutable means we cannot change our strings, but we can change our lists. So visual pins equals, there's nothing. And what we're going to do is say visual pins dot append, and we're going to say, we're going to append the letter, for God's sakes, append I, capital I. And we're going to print visual pins. If we run our code, we run something like 10, 3. How do we print these up? Well, just put that. And we say 10 and 3. We have I's. But how do we get it without space? Remember, separation equals, and put nothing. That's a new trick that you learn. Run this code, 10, 3, and we have our bunch of I's. If we said 23, 20, and 3, whoops, it'd be a bunch of I's representing my pins. So we have our visual representation of pins. We have all our pins there, and it's in our form of our array. Now what we want to do is we want to say for I in range for balls. And we're going to do this 3 times. So we're going to say first pin equals balls, equals, actually, what do we do 3 times? We have to take in input. Control C. Now, let's just say ball. So we're going to take in 2 inputs now. Our first pin is going to be equal to ball 0. In fact, we should add 1 to it because to make up for our index. So if our first pin was 1, it'd actually be pin 0. So we actually minus 1 to reset our indices, right? So if we add in 1, well, we want this to be taken out. But if we refer to our array, it would point to this. If you don't understand this, take a second to make sure you understand this. Last pin equals ball 1. What are we talking about when we say ball 1? We're talking about from the input, this value right here. And we're going to say index 1, the second index. And we're going to take in minus 1, right? Because look, if this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we want this last number to refer to this. So we're going to subtract minus 1 from it. And now what do we do? So for that ball, we take away, we get our first pin, we get our last pin. So what do we want to do? We want to say for I in range, and we want to start from our first pin to our last pin. And what do we want to do? We want to say, in fact, say last pin plus 1. I know we subtracted 1 when we added 1. You can change it if you want, but I hope you can follow the logic. So what do we want to do? We want to say that we're going to say visual pins dot I equals dot. Whoops. Dot. And we're going to go from our first pin, so let's say 2, 3, 4, to our last pin, including that. And let's see if it works. Let's print visual pin afterwards. Control C. Print visual pin now. And let's see what happens. Let's run our code. So let's say 10 and 3. So that prints up all my pins. Let's say 8 and then 10. This represents my pins that are knocked down. So 8, 9, and 10 are knocked down. Let's try another one. 2 and 5. Oh, there we go. We knocked it down. If we say 3 and 6, looks like everything's working. So instead of printing it out each time, let's print it out outside our loop. Let's not print this first time. Comment it out. And I already know it's working. Let's submit. And that's how you do 7D.